Hello everyone, welcome back to my channel. Today we are going to solve another interesting problem from the Green 169 Total DSA Problem Tracker. This Green 169 DSA Problem Tracker, till now we have already solved problem from the array, linked list, matrix, and right now we are solving problems mainly from the intervals. In the intervals, you can see I have already solved the problem insert interval and merge interval. Now in this session, in this video, we are going to solve non-overlapping intervals. I highly recommend you please try to insert interval and merge interval before watching, because that's the backbone for you to think about how you can merge, how you can think about non-overlapping intervals, how you can remove them. In the following session, you will see the different types of problem mainly from the two pointers, sliding window, string, queue, map, stack, binary search programming, binary search tree, then dynamic programming, and several kind of problems. Without further ado, let's get started. Okay, so this is our problem statement. So given an array of intervals with intervals start and end, we have an interval. There are containing start and end. Written the minimum number of intervals you need to remove. So you can highlight that minimum number of intervals to make the rest of intervals non-overlapping. Okay, which one note that interval which touch at one point non-overlapping. So they have given a condition like for example 1 2 and 2 3. These are the two. Though they are touching, but they are not considering that as overlapping because they didn't want to consider that condition. So while doing the calculation, we'll consider that condition. Now just try to understand what they are expecting, like you need to return the minimum number of intervals you should remove so that you can get the correct output. For example, in our first case, that intervals is currently intervals is 1 2, then second is 2 3, third is 3 4, and fourth is 1 3. So this is my interval, and if I just try to draw where when it can find that interval is overlapping or not. So 1 2 3 4 5, right? These are my array, and this is 1 2. Okay, this is 1 2 2 3, this is 2 3, this is 3 4, right? 3 4, and this is 1 3. This is 1 2 3, 1 2 3 4 and 5. So if we see just example, like they already clearly mentioned that this is not overlapping, right? This is not overlapping, so it is not the same, it is different one, right? If you wanted to just think of this, okay, 1 2 is already visiting to each other, but as per the note which they have given, that we are not considering that as an overlapping, so we will consider it as this separate. But if we see like the third one, right, it is already overlapping with this one and this one. For example, if we remove this, right, still for example, if we just completely remove this one, for example, I will just remove this, and we have 2 3, right? Still we are having this 1 3 which is overlapping with 2 3, right? So in that case, can I consider that as a minimum? No, right? If I go with the second, right, for example, if I remove just 2, right, we have removed 1 and we have already removed 2 3, right? So in that case, yes, we can say that we can get, by removing 2, we will get the exact intervals which is not overlapping. But the expectation from output is that we wanted to find this number as minimum, not maximum, right? Let me rephrase you. For example, if we remove this, then we can consider that as we have removed first. If we remove this, then after removing two first interval, then we will getting to know that yes, after removing two intervals, we will be not having any single intervals which is overlapping, right, which can't be found in between. So in that case, it's two, but our expected is that if we, by removing the minimum number of, instead of removing two, if we just think that I can remove this, okay, so if I think that I can remove just 3 1 3, if I remove just 1 3, then I will be going to get answer that there is no other intervals which is overlapping with each other, and I can get the answer, and the answer would be 1, because we can remove the one interval only from that list, and that's how we have to find the output of it. So if we just remove this interval, then I think we are already sorted. We don't need to remove extra, and that's what our output is expecting us to do. Now think about the approach how we can target trying to solve this problem. What is the first task? That we have given the input in different way. So first, like we wanted to compare it, right? We wanted to compare whether we can compare with that and how we can move that. So what I will do, the first thing, if I wanted to compare that, those two elements should be neighbor, so that I can look around and try to go for the next element. So firstly, I will just try to sort it. Okay, firstly I just need to sort it. Yeah, sort it. So when I will do the sorting of this, how it will change? It will be 1 2, then 1 3, then 2 3, then 3 4. Okay, this is what I am able to get right now. What I will do, I will store this somewhere because I wanted to do the comparison from first to second. So I will try to keep a store of this, because when the both element are same, I am not considering that as an overlap, right? When both element are same, I have already explained you over here, right? If both the element are same, that I am not considering it as overlapping. When you can consider if it is less, right? For example, if I'm ending here and I'm starting here, right? For example, this was the right 1 3. So if these two are colliding, right? If those two are less than the number which we are ending number of that, so in that case I can consider this is overlapping, and I have to remove, I just have to do the count of that. So what I will do, I will start 2, and I will try to compare with first, the next element of the first, whether that is less than or equal to, that is less than or less than, because I don't want to consider equal to, that's condition is getting rid of. So if it is like, if it is greater, right, and if it is smaller, what does it mean? It means that its overlap is happening, and as and when I see the overlap, I will directly increase the count. But in the second stage, what I will do, right, because we have already considered that, and I wanted to find the minimum, so that I won't be duplicating that. So what I will do, I will just try to, before moving to next, I will just try to do a the minimum of that, because we have already removed that. So I will just try to do the minimum both between both of them. So 1 2 and 1 3. So if I just do the minimum of that, then I can get easily able to get 1 2. So I will just having the second element, when I will iterate for the second time, I will have the 2 element with me. Second time it will start from here, right? And I will try to see whether 2 is less than 2. No, right? No, it's not. So what I will do in that case, once it is not, then I will try to find, replace the last element where I have visited by second element, by the current intervals second element, or you can say the end element, and I will repeat the same, right? When for example, when we are here, right, my input is here, and I will try to check whether 3 and 3, is 3 smaller? No, it's equal, but we are not considering that. So in that case, we'll just replace the last element, last ending element is with 4. And in this case, you can see we were having only single comparison when we have, where we have replaced the count. Okay, so I will just try to write a dry run, right? I'm just trying to sorting it first, right? You have to sort it, right? And okay, so for example, function find the intervals, right? Intervals, then count would be something I required. What else I required? I required something to be, just sorting it. I will do the sorting. Intervals dot begin, and then intervals dot end. So I have written code, but in pseudocode, you can just consider that I'm just doing sorting. Then what I'm doing for the first element, I'm just trying to find the ending element of that. So what is the last end? It's interval of 0 and the second element. And the for loop, I will be starting with 1 to n. Okay, I will be starting with 1 to n. Right now, what I compare, what is the important thing which I need to compare? That the element which is there, right? The element which is there, I just wanted to compare that with whom? With the first element. How I can find the first element? If, okay, if my interval, right? My interval of current, right? I and 0. If it is greater, right? If my current element is greater, how I can compare? Last ending element is greater. It means that I found the count. If I go back, right? We were comparing this with this. If this is greater, right? If this is greater, or we can write the reverse condition like, if last ending is greater than with whom? Intervals of current and the first element. If it is greater than, it clearly indicates that it's a count, right? When we're comparing 2 with first, it says that 2 is greater, so that's why we increase our count, right? And we increase the count. In that case also, we have to make sure that though we are removing, need to take the smaller element between first interval and the second interval. So I will just make sure that in the, before moving ahead, I will just do the minimum of both of them. With both of them means last end and intervals of I and 1. So whichever minimum between both of them, I can find it. And if it is not matching, right? If it is not matching, that what I will do, I will just try to replace the last end with the element which is in the last, and which is in the last is interval of I 1. That is second element. And once it is done, so what is the count we were having? We will be able to return that. Now let's try to just write the code. Okay, so for example, what was the first step that we did? We just sort it, right? Sort it. So sort intervals dot begin and intervals dot end. Okay, then what is the next step? That I need to declare a count which is currently 0. Also need to declare last end. What was the last end? That intervals of first and the second element. Okay, then I will start my I is equal to 1. I will move up till intervals of dot size. Okay, then I will just increase this. What else? If right last end is greater than with whom? Intervals of I and that to the starting element. If this is greater, right? This is greater. What it mean? It means that we have found that element inside it and it's overlap. So I will straight away increase the count and also increase the last 10 because in the second interval I don't want to keep the next element because we have already found the interval. So I will just take the minimum between both of them. So minimum of last end and intervals of second, which is between both of them. I will check them. Else, if it is not matching, right? If it is not matching, then are we gonna consider that whatever the last element we were having, like whatever the things we do here itself, we will just replicate. But here we are not taking the first element, we are taking whatever the ith element currently it is. And in the last, I will just return the count. Let me just try to run this and let me see whether the solution which I have written is getting accepted or not. Okay. So it's simple, but you sometimes you have to understand what is the problem statement is expecting for us to do. For example, you can see here it is saying that all the solutions which is there, it is getting accepted. Like for example, if we see 1, 2, 2, if we are getting 2, here 3, we are getting 3, and we also verified it with the minus integer as well. Let me try to submit this. Yeah, so it is getting accepted right now. Think about the time and space complexity. What is time complexity for this and what is the space complexity? So clearly what we are doing, we were sorting it. So clearly it's of log n log n, right? So O of n log n, because we are using the n log n, it's the base complexity plus. Are we using any different? We are doing iteration or from the entire n. So it's of n again. What is the maximum between the both of them? It's O of n log n. Are using any different data structure to process and store, right? We are not. So space complexity would be O of 1. I think with this, we'll conclude this video and we'll try to see the similar in the following session. Thank you. Bye bye.